So, write the following on your notes. We've got 10 to the negative 6th, 10 to the 4th, 10 to the 9th. If you are asked to evaluate or find the value of a power of 10, you're either adding zeros to the right or adding zeros to the left. Do you guys remember doing decimal places and moving them when you did power of 10s before?
Yep.
Hopefully. So, if we look at the first one and use the idea of what we just did in section 7.1, if this has a negative exponent, is 10 a non-zero number? Yes, it's not zero. So what do? You take the non-zero number and you do 1 divided by the non-zero number to the positive exponent. What is 10 to the 6th power? How many zeros would it have?
10
It would have 6 zeros. So it would be 1 over 1 and then 1, 2, 3, 4, 5, 6. So that's 1 million. What does that look like as a decimal?
5 zeros and I still don't understand how it's not negative.
It's not negative because the 10 is not a negative number. You're just moving the 0.
But the 6s.
Yeah, so that makes it become a decimal.
Question.
Is there any way for you to do any exponent and get a negative number on a positive? If you square a 10, do you get a positive or a negative? If you cube it, positive. You take it to the 4th, positive. If you take it to a negative 1, it still becomes a positive. If you take it to a negative 2, it still becomes a positive. It doesn't go to a negative. Unless there's a negative in front. Okay, so we got that one. Yes.
So the exponent, is that just saying how much zeros there is?
Yeah.
So like the 10, you don't have to use that 0?
No.
Alright.
You don't use that 0. If we had to do 10 to the 4th power, how many zeros would that have?
4.
4. So it would be what number?
10,000.
It is 10,000.
4 zeros, right? If you don't trust your instincts, pull out that handy-dandy calculator and type in 10 to the 4th power, and you will see a number there with a 1 and 4 zeros. How many zeros would 10 to the 9th have? 3, 4, 5, 6, 7, 8, 9.
1 bill. Guessing it.
So 1 billion. So now let's think about the decimal form. Let's go here. These are already good to go. How many zeros would be in front of the 1 if I were to write that as a decimal? So it would be 1, 1, 2, 3, 4, 5, 6. I'm just going to put a whole bunch here. Where would the decimal fall?
It'd be right between. It'd be at the 5th.
Yeah, right.
So if I move my decimal over, so here I go over 1, 2, 3, 4, 5, 6. If I start here and go to the left, it would be 1, 2, 3, 4, 5, 6. So how many zeros do you end up with? 5, right? So now I'm zoomed out. So 1, 2, 3, 4, 5, 6. Okay. Do you guys remember doing this? Did you do this in science this year?
Yeah, for like 2 days.
So you guys haven't touched scientific notation in science yet?
No, we did it for like 2 days.
All right, I'm going to give you a handy dandy. All right, so now let's do the reverse.
Oh, just count the zeros.
So now I'm going to give you the number, and now we're going to rewrite it as a power of 10. So our first number is 1 million. So it's going to be 10 to the 6th power, right? Okay. Now let's go to B. The decimals make it a little bit more complicated. What's that one going to be? Okay, so now if it was 10 to the 4th, wouldn't that be 1, 2, 3, 4? Yeah, so it's going to be to the negative 4th, right? How do we get that? How many decimal places do I need to move? 1, 2, 3, 4
Boom.
to get after the 1. So it'll be 10 to the negative 4,
Oh yeah.
right? Okay. How many decimal places do I need to get to the 1? 1, 2, 3, 4, 5, 6. That's why it's to the 6th power, right? Or just however many zeros that are there. Okay, so we got our powers of 10. So now let's use our power of 10, bless you, to do some multiplication. If I have 23.89 times 10 to the 8th power, what's that going to do to my number? It's going to move my decimal place to the right or to the left? It's going to move it to the right. How many spaces? 8. All right, so if I move it to, that gets me to after the 9, right? So that gets me 2 decimal places, which means I need to add how many zeros?
6.
6. Does everybody see why it's 6? Because it's 8. 2 of my decimal places move to get here. So that means I need space fillers for 6 more. So if I rewrite it as 2, 3, 8, 9, 1, 2, 3, 4, 5, 6. Fill in your zeros. 1, 2, 3, 4, 6, 7. I didn't do enough loops. 8. Right? So then it's 1, 2, 3, 4, 5, 6 zeros. So what's that number? Something giant?
23 billion.
So that's a 3. That's
No,
a.
2,389,000,000.
No, that's 2,389 billion.
That's
Yeah. Well, here's your million, here's your billion, so here's your trillion,
Oh, what?
right?
No.
No, this is your 100,000, sorry. Million, billion. So 2,389,000,000. That's it. All right, next one. 467 times 10 to the negative 3. Where's my decimal going to move? To the right or to the left? So 1, 2, 3. So it becomes 0.467. Right? Just moving them? Okay. So now this leads us to scientific notation.
Get on to the right.
So what's the purpose of scientific notation?
Make things easy.
Right, instead of writing out 2 trillion, whatever the number was, we can write it in,
384,000.
right, instead of writing out all of those digits, we can use scientific notation to write it a little bit more condensed. So scientific notation is a method of writing numbers that are very large or very small. Now on your calculators, it will do scientific notation, not the cheapo calculators, if you have a good calculator. It does write things out in scientific notation form. Let me pull up my calculator, my computer.
Oh, I got it right here.
You got it. The boy got it.
And a lot of times it'll pop up with the letter E. I don't know why it uses E. It does use X. Can I get rid of this slide?
Yeah.
So if you look at this calculator, if I were to do, let's say, what was the last example we had? 287 times 10 to the, let's make it giant, 9th power.
20th.
So notice how it turns it into scientific notation. It uses the letter E instead of a times 10 to the 11th power. So if this ever pops up on your calculator, we would just rewrite it as 2.7 times 10 to the 11th power. I don't know why they chose E. If it was an X, then you might think it means multiplication.
I don't know if I remember that. Can you write that on the day of the test? That when it shows up with the E, just write 10 to the certain power.
Well, that's what you should remember that it is. You should remember that. Does anybody's calculator use something other than E? What does yours come up with?
It goes straight up.
Mine just uses the number.
It says 2.87.
Yeah, mine says 10 to the 11th.
Same.
Oh, it does say 10 to the 11th power?
Yeah.
That's fancy. Look at that. That's even better.
Hey, you got it.
All right, so let's talk about scientific notation. So here is something that's written in scientific notation. 1.2 times 10 to the 5th power. And I want to put it to standard form. Now, this could be a little bit confusing because we did talk about standard form before when we were writing equations of lines. Remember, ax plus by equals c, we also called standard form. In this case, when we're talking about standard form, I'm just going to write it as the actual number. So, 10 to the 5th power means I'm going to move the decimal to the right or to the left? Right. To the right, how many spaces?
4.
10 to the 5th power means I'm going to move it 5. So, right now my decimal is in between the 1 and the 2. I'm moving it to the right. I'm getting larger. So there's 1 decimal move. There's a 2nd. There's a 3rd. There's a 4th. There's a 5th. I need to put numbers in place of that. So that means I'm going to have 4 zeros. So 1, 2, 1, 2, 3, 4 zeros. So it would be 120,000. Right? Aiden, I know this stuff is easy, but I need you to pay attention. What would the number be if it was 1.2 times 10 to the negative 5?
Don't go back, you know.
So if it was 1.2 times 10 to the negative 5, I'm going to move my decimal where?
Back.
To the left. 1, 2, 3, 4, 5, which means how many zeros are going to be in front?
4.
1, 2, 3, 4. So it would be 0.000012. Okay. So, given scientific notation, can you take it to standard form?
Yeah.
Can you do the reverse? Given the standard form, write it in standard or scientific notation. If I give you the number
What would that be? 142.7 times
14.27.
1,427,000,000 in scientific notation.
is 1.42.
Yeah, so when you do scientific notation, the important thing is you can only have 1 digit in front of the decimal, which means I'm going to put my decimal between the 1 and the 4. So it would be 1.427 times 10 to the,
9, 4,
so
5,
3,
6,
6, 9 would be the scientific notation. So far pretty easy?
Yeah.
This is easy stuff. Hopefully don't make it too complicated. Okay. Can you now order numbers from least to greatest, given them being in scientific notation?
Is the 1.3 times.
All right, let's get people a chance to write these down. Your first number that you should be writing down in your notes, gentlemen, is 1.3 times 10 to the negative 2 power, 6.3 times 10 to the 3rd power, 4.1 times 10 to the 6th power, 2.1 times 10 to the 6th power, 1 times 10 to the negative 2 power. So we're going least to greatest, so smallest to largest. My smallest exponent up here right now is what? Negative 2. So now I'm going to compare my first and my last to decide out of those two which one would be the smaller number. Now remember, we're doing we're doing decimals. So this would be equivalent to what?
Got it.
It would be 1, 2. So this would be 0.01. Over here, this would be 1, 2.013, which is smaller out of those 2 digits.
Bingo.
Right? 0.01 is smaller than 0.013. So that's going to be the first one. So 1 times 10 to the negative 2.
And the second one is the one on the left.
1.3 times 10 to the negative
And
2.
The third one is
What's going to come next?
3 times 10 to the third
Yep, the 10 to the 3rd power.
And the fourth one is at 2.1 times 10 to the 6th power.
Why did you choose that over this, Colin?
Because
is smaller than, good. So 2.1 times 10 to the 6th, 4.1 times 10 to the 6th. All right, so what I do have for you guys
Homework.
is a quick, no, not even close, quick
Why?
graphic organizer that might help you stick this stuff in your head.
Looks like home.
AI. Next conference.
Colin, the next time you get out of your seat without permission, you're getting a detention. So please stay in your seat. You've no need to be getting up right now. All right, so let's take a look at this graphic and how everything is working out. So we've got our powers of 10. If you have a positive exponent, we're moving the decimal point to the right. Here it gives you a series of examples. So 10 to the 8th power means I'm moving the decimal that falls after the 1, 8 places. Okay, over here, negative exponents means that you move the decimal to the left. So if you had 10 to the negative 6th power, starting after the 1, you go to the left. 6 units, or 6 places. Here's some other examples. 32.6 times 10 to the 5th means we're going to move the decimal to the right 5 places. Over here, 4.09 times 10 to the negative 3 means starting after the 4, move to the left 3 places. Then it leads to scientific notation. So what I would like you to do right now is, using everything we just did knowledge-wise, complete problems 1 through 9 on the bottom. And come up with answers, please.
Is this homework?
Nope, this is now work.